Okay, now I'm going to go over the review guide I gave you at the end of class. Hopefully this will help answer any questions. It's a little bit of older stuff that we're reviewing. So share screen. Okay, so we got some situations here. Computer games, we're talking about four-sided die, and we're trying to figure out what is the sample space for rolling the two dice. So if you think about it, when you roll two-sided dice, this is really what's going to happen. You're going to get a 1, a 2, a 3, or a 4. That'd be on my first roll. Let's just do this in a different color. I'm going to get a 1, a 2, a 3, or a 4. And this would be on my second roll. So if you think about it, the first roll is going to give me a 1, a 1, a 1, or a 1. My second roll is going to give me a 1, a 2, a 3. My second roll is going to be 2, 2, 2, 2, 3, 4, 3, 4, 3, 4. That's really what I'm saying is this. When I roll those dice, I end up with a 1, a 2, a 3, or a 4. A 1, a 2, a 3, 4. A 1, a 2, 3, 4. So those would be my sample space right in there, the 16 different outcomes. And the way I said to remember it is how many outcomes you are to how many events you're doing will tell you the size of your sample space. So in this case, I have 4 outcomes when I roll a four-sided die. I'm rolling it twice. 4 squared tells me there are 16 possible things in my sample space. So this guy right over here is my sample space. Sample space. That right there is my sample space. What is the assignment of probabilities to these outcomes in the sample space, assuming that the die is perfectly balanced? So what the outcomes are, if you think about it, what are all the possible outcomes when I roll this dice? Well, the way I roll the dice, I can get a sum of 2. I can get a sum. So again, this is a sum of 2, a sum of 3, a sum of 4, a sum of 5, a sum of 6, a sum of 7, and a sum of 8. The outcomes, each individual outcome actually has a 1 out of 16 chance of being done. There's 1 out of these outcomes out of 16 of these possible. But I'm going to kind of roll them together. So these are my outcomes and these are the probabilities. The chances of me getting a 2 are 1 out of 16. So that's this guy right here. That's my 1 out of, that's my 2. The chances of getting a 3 are these 2. It's 2 out of 16. The chances of getting a 4 are these 3. 3, 1, 2, 2, 1, 3. That's 3 out of 16. The chances of getting a 5, 1, 2, 3, 4. 4 out of 16. The chances of getting a 6, 1, 2, 3. 3 out of 16. A 7, 2 out of 16. And an 8, that's just that 1 way out of 16. So those are all my probabilities. So this is kind of my probability model if you're asking about all the possible outcomes. So that's my probability model. That's my prob model. Okay. Look at the next question. Next question says, if the event A is defined as a sum of 5, what is the probability of A? So in this case, the probability of A would be that 4 out of 16. Sum out of 16. And again, 4 out of 16 is fine. We're not going to turn it into 1/4. We're not going to turn it into 0.25. We're just going to leave it as 4 out of 16. Okay. Next. Number 2, here's a probability model for the 2013 AP Stats exam. Showed that it's a legitimate probability model. And again, the way that we want to do that is we want to go ahead and add up all those numbers. Again, to prove it, we want to add up those numbers. So what I'm going to do is 0.235 plus 0.188 plus 0.249 plus 0.202 plus 0.126. And what I want to do is I want to show that that adds up to 1. So if I did it in the calculator, you find out that I in fact does add up to 1. So since all probabilities are between 0 and 1, and the sum of all of them equals exactly 1, It's a valid probability model. It's a valid probability model. Okay. So that's number one. Find the probability that a chosen student scores 3 or better. So I would need to add those up. Probability that the score is greater than or equal to 3. So what I'm going to do is I'm going to add up those last 3 numbers, the 249 plus the 202 plus the 126. So again, calculator is going to be my friend. 0.249 plus 0.202 plus 0.126, so 0.577. So in this case, the probability of getting a 3 or better is a little bit greater than 57%. There's my work, there's my answer, there's my complete sentence I gave the thing. So this typically is not a complete sentence because you left out context. This is not complete work because you didn't show my work. And then again, leave that as a decimal because we started as a decimal. Hopefully that helps that one. 3, again, reading probability models. All human blood type can be typed as OA, B, or AB, but the distribution of the types varies a bit. With race, here's a distribution of the blood type of a randomly chosen Black American. 0.49, 0.27, 0.2. How are we going to figure that out? And again, if you remember, you figure that out. It all has to add up to 1. So we do 0.49 plus 0.27 plus 0.20. And that's going to be 49, 76, 96. So the probability of someone having O, A, or B blood is 96%. So the probability of having AB is 1 minus that 0.96. So that is 0.04. Probability of having AB is 4%. And why? It's because we just showed that work. Okay. What is the probability that the person chosen does not have type AB blood? Well, we just literally did that. That's that guy right there. The probability of not AB is 1 minus the probability of having AB. So it's 1 minus 0.04, 96% chance. Maria has type B blood. She can safely receive blood transfusions from people with blood types O and B. What's the probability that a randomly chosen Black American can donate blood to Maria? So again, what I'm looking at is she said she can take it from O and B. In this case, what that means is these are mutually exclusive. You can't have 2 different blood types. You're allowed to add those together. So to answer the question for Maria, we say the probability that she would find O or B is going to be the probability of O plus the probability of B. And those numbers were 49 and 20, 0.49, 0.20, 0.69. And again, that's like complete sentence. You've given me the sentence, you showed me how you got it, the work, and then the answer. So that's 3. Now let's talk about number 4. Okay, we're gonna skip 4. Actually, we had this on another sheet. I don't like this question, so we're just gonna skip 4. Okay, now, probability standard deck of cards. You draw 1 card, determine. This is again that stuff I said at the very first day of class. There are 4 kings in a deck of cards, so it's 4 out of 52. Red cards, half the deck is red, 26 out of 52. Face cards, Jack, Queen, King. Those are the face cards. There's 3 of them. There are 4 suits. 3 times 4, 12 out of 52. A black ace. Well, that would be the ace of spades or the ace of clubs. That would be 2 out of 52. Jack or 9. Okay, it's mutually exclusive. You can't be a jack, you can't and a 9 at the same time. So there are 4 jacks, there are 4 9s. 4 plus 4 tells me that that's 8 out of 52. A queen or red. Okay, this is going to be one we got to pay attention to because this one is going to say the probability of being a queen plus the probability of being red minus the probability of being a queen and red. So if you think about it, there are 2 red queens in the deck, the queen of diamonds and the queen of hearts. We count them here, but we'd also count them here. So what that would say is that there are 4 out of the 52 cards are queens, 26 out of the 52 cards are red, but I got to subtract that double counted queen of diamonds and queen of hearts to subtract the 2. 4 and 26 is 30 minus 2. It's 28 out of 52. Probability of being red or black, mutually exclusive world. Can't be both. So it's the probability of red plus the probability of black. It's the whole deck. It's 52 out of 52. Probability of being queen and red. Well, we just did that up here. They're the queen of diamonds and the queen of hearts. So 2 out of 52. The probability of being red and black. Notice that's different and it's impossible. 0 out of 52. So it's a little bit of a more straightforward kind of review on this one. But again, remember your deck of cards thing we talked about. So hopefully that helps. I'll put this up on the day 5 stuff. So hopefully that you can use that to check your work.